Physics Part 100. A safety feature of modern car is the airbag, which in the event of a collision inflates and is intended to decrease the risk of serious injury. Use the concept of impulse to explain why an airbag might have this effect. Number 4, two frictionless trolleys, A and B of mass m and 3m, respectively, are on horizontal track. Initially, they are clipped together by a device which incorporates a spring compressed between the trolleys. At time t is equal to 0, the clip is released. The velocity of trolley B is u to the right. A. Calculate the velocity of trolley A as the trolleys move apart. B. At time t is equal to t1, trolley A collides elastically with a fixed spring and rebounds. Compression and expansion of the spring takes a negligible short time. Trolley A catches up with trolley B at time t is equal to t2. Number 1, calculate the velocity of trolley A between t is equal to t1 and t is equal to t2. Number 2, find an expression of t2 in terms of tv. Find an expression of t2 in terms of t1. C. When trolley A catches up with trolley B at time t2, the clip operates so as to link them again, this time without the spring between them, so that they move together with velocity v. Calculate the common velocity v in terms of u. Initially, the trolleys were at rest and the total momentum of the system was 0. However, the answer to C shows that the total momentum after t is equal to t2 is not 0. Discuss this result with reference to the principle of conservation of momentum. Number 5, a ball of mass m makes a perfectly elastic head-on collision with a second ball of mass m initially at rest. The second ball moves off with half original speed of the first ball. A. Express m in terms of m. B. Determine the fraction of original kinetic energy retained by the ball of mass m after collision. We will be talking about thermal physics in our next chapter, in our next videos. And this is end to it right now. And we will be bringing more discussion as we go along with it. So, we have certainly, I can give you a big bit of introduction to chapter 6, thermal physics. The aim of this chapter is to describe a number of phenomena associated with temperature and thermal energy. We shall start by looking at the physical basis of the thermometers, which are instruments to measure temperature, and then see how scales of temperatures are defined. The fundamental scale of temperature, the thermodynamic scale, is based on the properties of an ideal gas. To develop the idea of temperature of a gas, we shall need to think of the gas as a collection of very small particles in continuous random motion. This is the basis of kinetic theory of gases. Finally, we shall consider the energy of particles of a gas and link this internal energy to the quantity of work and heat through the first law of thermodynamics. So, our chapter number 6, thermal physics.